The acronym to help you remember the trigonometric ratios is SO, CA, TOA. SO is sine of theta equals opposite over hypotenuse. CA is cosine of theta equals adjacent over hypotenuse. And TOA is tangent of theta equals opposite over adjacent. We're going to use these trig ratios to completely solve this triangle. Step 1. We need to find the length of the missing side. We know two sides of this right triangle. To solve for the missing side, we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. So 16 plus question mark squared equals 36. Subtract 16. Question mark squared equals 20. Take the square root. Question mark equals the square root of 20, which we can simplify down into 4 times 5, which turns into 2 square roots of 5. So my unknown side is 2 square roots of 5 long. Now to use my trig ratios in this problem, I have two acute angles, angle A and angle B. And I'm going to look at each one of these angles separately and use the trig ratios. I'm going to start by looking at angle A. I want to first find the sine of angle A. Now sine is opposite over hypotenuse. So if I look at my triangle, 6 is my hypotenuse, and if I look at angle A, 2 square roots of 5 is opposite of angle A. So the sine of A is 2 square roots of 5, the opposite side, over the hypotenuse. Now I can simplify this fraction. 2 divided by 6 is 1/3. So this simplifies down to the square root of 5 over 3. Now let's keep going with angle A. If I look at the cosine of angle A, cosine is adjacent over hypotenuse. Well, my hypotenuse is 6, and adjacent to angle A is 4. And 4/6 can be simplified down to 2/3. So the cosine of A is 2/3. And finally, tangent. The tangent of A is opposite over adjacent. Well, opposite of angle A is 2 square roots of 5, and adjacent to angle A is 4. So the tangent of A is going to be 2 square roots of 5, the opposite side, over 4, the adjacent side. And again, I can simplify this fraction. 2 divided by 4 is 1/2. So my fraction is the square root of 5 over 2. So the tangent of A is the square root of 5 over 2. Now if I switch angles to angle B, if I look at the sine of angle B, sine is still opposite over hypotenuse. Now if I look at this triangle, when I switch to angle B, my hypotenuse doesn't change, it's still 6. But what does change is my opposite and adjacent side. Opposite of angle B is 4. 4/6 simplifies down to 2/3. So when I switch angles, my hypotenuse stays the same, my opposite and adjacent sides switch. So the sine of B is 2/3. Cosine of angle B. Cosine is adjacent over hypotenuse. My hypotenuse is still 6, that doesn't change. But when I'm looking at angle B, adjacent to angle B is 2 square roots of 5. 2/6 is the same as 1/3. So the cosine of b is the square root of 5 over 3. If you notice, there's a relationship between sine of a, cosine of b, cosine of a, and sine of b. Finally, tangent of b. Tangent is opposite over adjacent. And if I look at angle B, opposite of angle B is 4, and adjacent to angle B is 2 square roots of 5. Now I need to simplify this. 4 over 2 simplifies down to 2, with the square root of 5 in my denominator. Now I need to rationalize my denominator by multiplying top and bottom by the square root of 5. 2 times the square root of 5 is 2 square roots of 5. The square root of 5 times the square root of 5 is just 5. So the tangent of b is 2 square roots of 5 over 5. So when I have a triangle, I have two acute angles. Each acute angle has 3 trig ratios associated with it. So I can take the sine, cosine, and tangent of A, and I can take the sine, cosine, and tangent of B, my other acute angle. So there's 6 total trig ratios in one triangle.